Assalamu alaikum. Our lecture for today is methods of prestressing. Contents: methods of prestressing: pre-tension, post-tension, bonded construction, unbonded construction. Methods of prestressing: the prestressing can be performed by two methods as shown. Pre-tensioning, we can see in this picture, the tendons is performed before casting of concrete and tensioning with the prestressing force. Post-tensioning, we can see in this picture, the concrete is casted before tensioning the tendons. Pre-tension. In the pre-tensioning technique, the stress is induced by initially tensioning the steel tendons. These are wires or strands that are tensioned between the end anchorages. After this tensioning procedure, the concrete casting is performed. After casted concrete has hardened sufficiently, the end anchorages arranged are released. This releasing transfers the pre-stressed load to the concrete. The bond between the concrete and the steel tendons assists this transfer of stress. The tendons that are protruding at the ends are cut and finished look is achieved. In order to generate pre-stress force in the pre-tensioning methods, a large number of tendons and wires are used. This system hence demands a large area of surface contact to make the bonds and stress transfer achievable and need for large abutment. We can see in this picture, in A, applying tension to the tendon. One end is end abutment and the another is jacking system and tensioning the tendon before casting of concrete. We can see also in this picture in B, casting of concrete after tensioning the tendon. In C, we can see transferring of prestressing force to the member by cutting the tendon, and we can see the camber in the concrete member. In this video, we can see the system that is used for pre-tensioning member. The jacking system here and the abutment between the two ends, and we can see also here the tendons in the flange of the girder. Also, we can see the mild steel is used. Here, the jacking system. And controlling the suitable prestressing force that's subjected to the tendons. Post-tension, the steel is prestressed only after the beam is cast, cured, and achieves the strength to take the prestress. Within the overlay, the concrete is cast. For the passage of steel cables, ducts are formed in the concrete structure. After cast concrete hardens completely, the tendons are tensioned. One end of the tendon is anchored and the other end is tensioned. In some specific cases, the tensioning can be performed from either side and anchored subsequently. As shown in this picture, we can see making the duct in the concrete member to enter the tendons or strand or wire here after casting of concrete. We can see the system of jacking here when the tendon is put in this duct, and tensioning of tendon. And what we can see also in C, anchoring the tendon at stretching end, cutting the tendon from the other side. We can see in this video girder is casted in place for post tension.
That's 40 meter. Okay, it's 40 meters. Now the height of this girder is, you can see height of this is 2.4 meter, right? Now guys, you can see
the
its
duct
width is, you can see its width is 75 centimeter or 0.75 meter, but at the top you can see top flange is 1.1 meter. This is top flange and this is bottom. Bottom is 75 centimeter and top is 110 centimeter, guys. Now what's the use of this sheet pipes? What's the purpose of these sheet pipes? Remember guys that when they complete the concrete, okay, when they complete it from the concrete, okay, like this, you can see this is complete girder. Okay, when they complete it, okay, so after this they will put reinforcement in these for the stressing, and they will use here 15 numbers of steel bars, which dia should be 12.7 millimeter. Okay, and after 28 days when they do the farm work of this farm work for concrete, and after this they will do its stressing after 28 days when they complete its strength. Okay, when they gain its complete strength, after this they will do the stressing. Okay, now you can see this, these are the pipes. These pipes are called in technical terms sheet pipes, and using steel reinforcement, okay, for stressing. And this is called trumpet cone. Okay, trumpet cone. You can see here are 5 tendons. This is called tendon, 5 tendons, but they will remove this farm work. Okay, so it's farm work. Now you can see. Now come to its reinforcement details. Here total numbers of steel bars are, you can see here are 8 numbers of steel bars, guys. You can see, and the dia of each steel is 25 millimeters. 8 numbers of steel bars are used here,
tendons.
but after 6 inches you can see 6 inches. This is 20 millimeter die of steel, but here at the whip, okay, so this is slope. You can see here, this is slope, this is, it's called end block and reinforcement details. Okay, but I will also discuss this in full girder, okay, in complete girder. Now this is whip, this is whip, right? It's here 21 centimeter or 0.21 meter. Okay, but there you can see its slope, right?
After the prestressing process, there is a space between the tendons and the duct. This leads to bonded construction and bonded construction. Bonded construction The gap between the duct and the tendon is filled with the cement grout. The grouting process assists the steel to resist corrosion to a large extent. The final strength is enhanced as this method increases the resistance to live loads acting. The grout mixture is cement and water, compound with or without admixture. No sand is utilized in this grout. Unbonded construction. If no grout is utilized to fill the gap between the duct and the tendon, it is called unbonded construction. In this process, the steel is galvanized to protect it from corrosion. Waterproofing material is exploited for galvanizing. We can see in this video the process of making grout material by using cement with water only, without sand. We can see the grouting material is put it in the duct. Thank you.